Okay, good morning and happy Tuesday, my algorithm solving friends. So today I'll be doing LeetCode contest 317 virtually. So here we go. All right, open these guys up. Time to shine. Okay, divisible by 3 and the average. All right. Here we go. N equals, actually, let's do div 3 equals x for x in A if not x modulus 3. Turn sum div 3 divided by the length div 3. If length div 3, else 0, so we don't divide by 0. Okay, 9.0 and 0. Okay, rounded down to the nearest integer. So you want the floor, this guy. Okay. Oh, expected 0, output's 9. Uh-oh. All even integers? What? Oh, okay. I missed that part. Oops. Okay. And x modulus 2. Right, okay. That should be 0 and 0. Yay. Okay. Let's post this here real quick. Just call this okay. 2, 3. Sum of okay, length okay. Okay is a good name, I think. All right. Kotlin, JavaScript. Oops. Python 3. Rust. C++. Okay. That's cool. All right, let's do JavaScript next. Let's see, let okay equal a dot filter x at x modulus 3 and x modulus 2. Return okay dot length. O dash sum of okay. The floor of this guy, math dot floor, that guy divided by okay dot length. Else, oops, 0. Looks good. Looks good. Okay. Kotlin. Where's where Kotlin? There's Kotlin. Okay equals a dot filter. It modulus 2 is equal to 0. It modulus 3 is equal to 0. Return if okay dot size is greater than 0. Do math floor. Oh, actually, I think this is by default, so we'll do the floor. Okay dot sum divided by okay dot size, otherwise 0. Looks good. Excuse me. All right, that's cool. Let's do this in C++. Key. I'll do okay equals, actually let's do this. Yeah, okay. We'll back insert into this thing. Copy if a oops, let's do back inserter okay. X modulus 2 and x modulus 3. Return okay, that's size question mark. The sum of okay accumulate okay to in okay to end divided by the okay dot size, otherwise 0. Looks good. It's cool. Okay, it's rest time. Save the best for last here. Rest. Okay. 0 by 32s. Let okay. Cool. A dot into iter filter x modulus 2 is equal to 0 and x modulus 3 is equal to 0. Collect two effector integers and we'll return if okay dot length. Excuse me. It's greater than 0. Then we'll return okay dot sum map by okay dot length I32, otherwise 0. Whoa. Oh, okay. Iter. Oh. Sum of I32s. Oh, don't have to unwrap it. It's not optional. Okay, that looks good. It's cool. Okay. Filter the input array A on values x where x is evenly divisible by 2 and 3. Sounds good. Okay, let's move on. Most popular video creator. Okay, just try to find the most popular person and sum of all views in all the creators' videos. And then the ID of the most viewed video. Find all of them if they all have the same highest priority. Multiple creators. Okay, there's a couple corner case conditions here to consider. Creator and ID. an array of creators, an array of IDs. Okay, so we need high popularity. And then we need a high for count. Popularity Alice is 5. As 5 is 10. So Alice and Bob are tied for the highest popularity. The lexicographically minimum of Alice is 1 compared to 3. So we want per person popularity sorted lexicographically. Right, so see per person total popularity, all videos. And then per person video, highest popularity. Lexicographically minimum if tie. Okay, so we should be able to associate creator. I guess maybe we can do 2 pass. Total creator views. And then of the highest in those buckets, look at their videos. Views. Actually, hold on. Count of views, maybe we'll call it count. And is length of A, right, and range N. Counts of A sub I plus equals views sub I. I will be 0. I equals maximum of I. Count of A sub I. So now we can filter the names. Name for name in count dot keys if count sub name equals high. So those are the names of the best, and then we need the highest ID for each. We should associate the videos for each. Let's do this again. We'll reuse I in counter or I in range in. So this is per person, actually. So it could potentially TLE, do a pass per person. So we want to find the highest view count per person in names. For ID and name. Associate the IDs for name there. Just call this thing videos, about videos per person. Default dictionary list. Videos of the a sub ith person. Let's do this name equals a sub I. Count of this guy's name. Video of this guy's name. Dot append. IDs. Sigma I. Or name and names. The answer can be returned in any order. That's fine. Okay. Return the answer. The end. See. Okay, so we want to say I and count equals best and count. How about best is just empty string, count 0. For video and videos of this guy's name. If let's do this, IDs and views of I, video views. Best ID and best count. If best count is less than or equal to the count and just as less than the count, we'll set it best ID equals this guy ID. Video best count is equal to count. If best count equals count and best ID exceeds video lexicographically. Same thing. Let's do this, just best ID equals video. So for the lexicographically smallest. And instead append, best ID, best count. Okay, something like that. 1, 5, oh, we want the name. and then the video. Okay, so it's gonna be name and the best video, the best ID. Alice 1, Bob 2, and Alice B. Looks good. It's taking a while. Oh, output is A and blank. 0 views, huh? Okay, let me go to the ASCII table. The default value can't be an empty string because I want it to be lexicographically smaller. Let's just do the tilde then. Oops. Default will be this guy. Wrong answer. Oops. Oh, come on. Copy this guy. Stick it there. Be that thing. Should be AA, not a empty space. AA. It's good. Or you probably do -1 and then empty string, which is probably fine too. That looks cool. Okay, big money, no whammies. Yay! Okay. So not necessarily algorithmically complex, but it does take some time to write this and think about it. Okay, let's just post this real quick and move on. Nothing too fancy. Solutions. 3. Plan. JavaScript. So yeah, not necessarily algorithmically complex, but it is good practice just to be able to code. All right, so actually, let me see if I want to clean this up a little bit. Best ID, best count. Just call it best and then high. If high is less than the count, best is that video. High is equal to count. If high is equal to count, video is less than best. Best equals video. I just clean this up a little bit, right? It's cool. All right, so seem like decent enough names to me. That's high. Okay. Let's jam on this in the other languages real quick. Okay, an array of creators, IDs, and views. Let's see, we want to counter, so counter or purples, what do I call this thing? Videos and count. Count equals new map. Videos equals new map. For that name of A, or actually do this for I equals 0. Let's do this. N equals a dot length. As is an N. Name is a sub I. If not count has name. Count set name 0. Let's do this. Then if not videos as name, videos and set name to empty array, count get name, count dot set name 1 plus count dot get name. Actually, what 0 is probably fine. Okay, and then videos dot set name. Let's see, videos dot as name. Actually, I think we just want to do this better. Videos dot get name push IDs of I. Let's do this. Name video space of I IDs of I. Hold on, this needs to be view views of I. Name video view, count to the name, add view onto whatever is already there or 0. All right, and then push the video onto videos. Okay, so let names equal a dot filter. Copy this guy. Name such that we need the high. I equals 0. Count dot get name equal to high. All the names. Answer. Return the end. I'll let name of names. Best I. Equals empty string -1. So now we want to push the video and the view count of the video. If I is less than, let's do this. Count of each video. Video view count of videos that get name. If just got this guy count. I think I reused count over here too. All right, it's fine. Reuse count and high is cool. So if high is less than count, then let's just do this. High is equal to count and best equals video. If high is equal to count and video dot lexic locale compare best is less than 0. Best equals video. All right, and then answer the push name best. Okay. Uh-oh. Y is less than count. Uh-oh. You just get name, video, view. View count. Let's do this. Name, video. All right. It's not even considering these. Okay, so the filter is not working. Count at get name is equal to high. Oh, high is not set. Okay, so high. Count at max of itself and count at get name. Okay, so that's not quite right. ls1 is there twice. lsb is there 3 times. So it should be a set of names. So it's unique. It's strange though that worked okay in Python without a set. Oh, I know why. It's because in Python I was filtering on not A, but I was filtering on count. So let's do that because count is unique. Count on keys. That works. Okay, that was cool. All right, that's cool. I want to look real quick what these other folks are writing. Usually they're junk solutions. Yeah. Yeah. Someone complaining. Ay, ay, ay. You suck at coding. Okay. Kind of bummed to see these solutions propagate to the top because they're usually crappy. I'm thinking maybe I'll just change this back to view just so it's view count. Well, no, count is fine. Whatever, we don't have to perfect this thing. It's fine. All right, that's cool. We reuse high and count, but that's just fine. Let's just do this high equals 0. Yeah, that's cool. Okay, nothing too fancy. Okay, there we go. Let's do this in Kotlin. And again, yeah, this isn't algorithmically complex, but it is nice to practice, to be able to write code that's readable and concise. Okay, so high count equals a pair 0 and immutable map of string count integer, and then we want videos triple. Videos will be a mutable list, map of a mutable list, mutable map of name, mutable list of video name and video count. Okay, so for name, oops, I have this. Actually, yeah, let's destructure this thing. I'm gonna clean this up a little bit because we can destructure it in JavaScript and Python 3 as well. All right, so for name video view in, I wonder if we can zip all three of them. A, IDs, views. Name is this guy. View. Videos. Video. View. Counts of name. It's a little bit cleaner. No. All right, that's cool. And might as well just destructure them. Sure does take a while. Okay, yeah, that's a better solution. Just destructure those. It's a little bit cleaner. And let's do the same in JavaScript and move on to Python. Do the same thing there as well. Oh, I already. Wait, no, hold on. Oh, okay. Wonder if load-zip would work or not. Let's do this. Give it a try. For let's name video view of load-zip a IDs views. That's cool. Okay. Thank you, Lodash. Alrighty. Moving on back to Kotlin. Might as well destructure this thing for our name, ID. Oops, actually, we call this like video view in a zip IDs zip views. I don't know if this will work or not, so let's just print it out. Name video view turn list of string. So it compiles and prints. Mutable map of this guy. String. This guy needs another one of those things. Mutable list of pairs. Mutable list of pair. String int. Maybe that doesn't work. Let's see if this works or not. Zip those and then zip that. Durable pair. Wonder, maybe you can't zip a triple. Okay, well, whatever. For I n equals data size and 0 until n. Our name video view also triple sub I, ID sub I, views sub I, and account name equals the name could exist, otherwise 0. Views added onto that. Okay, and high equals the maximum of itself and the count of the name. And then videos. If videos that contains name, videos name equal to immutable list of pair string videos of name, add pair name view. Names equals count dot filter name view count so I just want to need the view count is equal to high map to the name or name and names. High is equal to pair empty string and -1 or video view count in videos name if I is less than the count, I is equal to the count, best is equal to video. Pick the answer. Mutable list of list string and so to list and list add list of strings, which would be name best if I is equal to count and video dot locale compare best it's less than 0 and best equals video, add the name of the best. Oh, how do you lexicographically compare? Hold on. Kotlin compare strings. String comparison. Compare to, I see. Oops. Video dot compare to best. Video is lesser than that. Looks good. Wait, no, hold on. Alice and Alice, it's not right. Best video. Oops, video. Video and view. There we go. Looks good. La 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 la. Come on, big money, no whammies. Big money, big money. Yeah. That's cool. Kotlin, JavaScript, Python 3, do C++ next. Using VS equals vector string. Using VBS equals vector VS. Yes. Using I vector integers. String and string IDs. Vector integers views. And size. Do all these i's from 0 to -1 inclusive. Do. Then we need create a map and such. So name video view I sub I v sub I view sub I, then total view count using counter equals unordered map of string integers. There, that guy. And using videos as an unordered map name, and then using pair is a pair video name and the video count. It's a vector of pairs, pairs, vector pair. Okay. Videos. All right. Business now here. Okay, so actually we need high as well. Let's do this. High 0. Okay, so count sub name equals view I is equal to the maximum of itself and the count. And then videos sub name dot in place back. And we're going to put the pair of the video name view. Okay, and then we need a vector strings names. Copy if. Actually, yeah, just do a set is fine. Otherwise, I'd have to grab the pair first. Yeah, let's just do this. Using set is unordered set of strings. That'll be people's names. Pf and and let's see, insert her names and name. Now this thing reference turn count of names equal to high. Okay, so for each name and names. Answer at the end here. The answer is a pair of strings. Answer equals a vector. Or actually it's VSS, right? Yes, answer. Okie dokie. So for let's do this. No best I equals pair best, I do -1. For each video count of its views and video's name. If I is less than count, I is equal to count, and best equals video. And if I is equal to count and video is less than best equals video. Answer dot in place back name, the name of the best video. Okay, something like that. Uh-oh, strings, unordered set of string, unordered best, oh, pair string. Oh, dang. It does not like that at all. Okay, so let's do this. Best, high 0, or actually -1. Oh man, really? What's going on? No matching constructor for the initialization of the vector. Where's it complaining about this at? What? Video repair. What is going on here? There's the culprit. Okay, yeah, so it's somewhere in here. Let's just print this out here. Names again, names end, string, liberator, string, see out, flush the output. Alice and Bob. Okay, so that looks right. Names. So what's going on here? My best video sub name. Should be able to iterate through this. Okay, all right, that should be fine. No, it doesn't like this. What the heck? For each name and names, place back name. I wonder if it doesn't like the R value move semantics there. And place back. Oh. Yeah, let's just push back a copy. Sort of a reference. Maybe that's what I was complaining about. Okay. Can't place it as we iterate over the set. Right, the R value move semantics is not making C++ happy. Big money, no whammies. Yay. Okay. Whatever, good enough. Oops, okay. Kotlin. Yeah, all right. Add a little description. Let's move on. All right, so use maps to associate videos name with view and name with persons, associate person's name with view count. And the person's name with each video, videos, view count. Yeah, good enough, right? And then you can read the code. Few solutions, pretty straightforward, right? Use a map count and videos, you filter on those names of the best. All right, it's cool. Nothing too fancy. All right, let's move on. How much time do we have left? We have 33 minutes left. Okay. Q3. Here's where things get a little bit more interesting, right? So 33 minutes remaining. Contest. Okay, here we go. Get some more coffee real quick. I'll be right back. Okay, back to the cockpit here. Return the minimum non-negative integer x such as n plus x is beautiful. It's beautiful if its sum of the digits is less than or equal to target. Into the 12th. Holy cow, this thing's huge. Target's 150. Start zeroing out from the right to the left. Zero out this guy. Okay. Game plan is to zero out each digit of n from, oops, right to left. Okay, this is what we have to add on to it. Need is what we'll return. We need to add on to n for it to be less than or equal to t. Just target. So f is our function which will accumulate the total digits of n. Which is a constant operation since there's 12 digits. Lambda x Suppose we could split it into an array and take the sum of that. Let's do this, call this thing in. Create a string from n and then turn each of those strings into an integer. Each character of the string. List of characters. While f sub n exceeds t, we'll zero out the rightmost digit. Digit equals offset. Let me call offset from right. Place it. Actually, maybe turn it into an array of digits. Array of digits might be easier to handle. Each digit you zero out by adding it up to 10. Yeah, that makes sense. Okay, x. A equals deck. Push it to the front as we reduce it. X a dot append left a modulus 10 a divided by equals 10. Let's do this right. Just make sure this is cool. It's the array. So the array here should be 1, 6. Uh-oh. That's for operand. Oops. X modulus 10. X divided by 10. Like 1, 6. Okay, cool. F equals, well, just the sum of the array. Well, the sum of the array exceeds our target threshold. Offset will be n minus 1 digit position. I equals length of a minus 1. There could be a corner condition when we have to append left onto the very last digit. Okay, so need plus equals 10 minus a sub I minus equals 1. A sub I equals 0. I zero that thing out. Need. Okay. I think that works. So it should be 4, 33, and 0. 4, uh-oh. 7's not good enough. So this is the wrong answer. 7 is insufficient. A sum of A. What we got here? Oh, we need to multiply it by the offset of I. Ten times offset ith offset 0 offset offset 1 set times that, and then offset times equals 10. Uh-oh, 43 offset, that should be 3, 4, oh, it only wants to go up to 9. If offset equals 1, put a 9 most of the time. Otherwise, for the very first digit, go up to 10. 33, 1, 0. Okay, that looks right. Uh-oh. Output's 1, which is not correct. Yeah, so there's some corner cases I didn't consider. 2 there. Hmm. Nineteen one. So what's left over is still bigger than the sum. Well, 0 is less equal to I, and that, then we'll print what's left of A. Should be 2, 0, right? Oh, it's 1, 0. I need to add it on to the next one. I see, okay. Add it on to the next one. Okay, hold on. I minus equals 1, offset there, and then if 0 is less than equal to I minus 1, then a sub I minus 1 plus equals 1. Otherwise, a dot pinned left 1. Make sure I got 1 over 81 is cool. Okay. So let's do this. Stick that there. Uh-oh. Yeah, so that one works, but then I broke these ones. Hey, hey, hey. 4. That's a 2. 16 and 6. Otherwise, I'll yeah. I'm gonna pin the 1. Oh, hold on. You said I is equal to 0. In that case, okay. Okay, something like that. Sounds good. 19 and 1. These ones. 433, 0, 81. That's good. Big money, no whammies. Yay. Okay, and then we got 17 minutes left. Okay. So we zero each a sub ith item from right to left, carry the 1. All right. Looks like I'm gonna run out of time for Q4, but I'll jam on this one. Few solutions in the other languages real quick. Kotlin, JavaScript, Python 3, C++. Okay. Python 3 is there. Do the deck. Push it onto the array. Accumulate the array. Offset them. All right. Nothing too fancy. X target array. File x divided by almost 10. A dot push x modulus 10. And then while sum of A exceeds the threshold, turn what we need 0. Okay. And then the ith offset I offset equals a dot length minus 1. Just hold on. Again, I don't need to check for I here. At the threshold. Hey, that's good enough. It's cool. Okay. The ith offset. Oops, hold on. JavaScript. Ith offset. Okay. Minus I offset times equals 10. And need plus equals 10 minus a sub I. A sub I is equal to 0. If I minus 1 exceeds 0, a sub I minus 1 is incremented by 1. Otherwise, shift a dot, oh, that's unshift actually. Unshift is pushed to the left. Unshift 1. Okay, that looks good. Nope, it's not good. Houston, we have a problem. Oh, times the offset, right? Set times this guy. Uh-oh. This does not look good. Plus a sub I minus 1. Minus I. Looks like it's bigger. Let's see. Let's just do this. So 4 is correct, but this one's way off. Console.log a. Whoa. Holy cows, okay. Times 10, that minus that. Why is this going on here? This does not look great at all. Holy cows, offset times equals 10. A sub I. X modulus 10, X, here we go. Math dot floor, X divided by 10. Okay, that looks good. That's cool. All right, stick these. Here, use these 19.1, which is cool. Should be 81 at the end. All right, that's good. Okay. Big money, no whammies. It's cool. Okay, JavaScript. Let's see. Let's do this. Transform the input digit x to an array of digits, then zero out the digits of a from right to left. Yeah, to accumulate we need for the sum of a to be less than, or to, yeah, less than or equal to threshold t. And nothing too fancy. Okay, there's x, target 1, x exceeds 0, x equals 10, and then array deck array equals deck array Kotlin, is it array deck yeah, it's array deck. Array deck integers a dot. What do you add to the left of this thing? Add front? Is it add front? Add first? Yes, add first. Okay. Add first x modulus 10, x divided by equals 10. All right. need will be at long. Need here in the end. So while sum exceeds the threshold t, need equals 10 minus a sub I equal to 0. If I minus 1 exceeds or meets 0, then a sub I minus 1 is divided by 1. Otherwise, a dot add first. And I wonder if we need that now. It has to be at least 1. Otherwise, yeah, just let it be zeroed out, right? Well, I'm pretty sure I can clean that up. I don't need this else. Right. Less code, the better. It's irrelevant, then don't write it. The best code we can write is the code we don't write. There's not a possibility of there being a bug that exists there. It's good. It's cool. Okay. JavaScript. Back to Kotlin. Okay, we don't need this else portion. Okay, I do want to decrement I and then increment the offset. Okay, and then I need I offset is triple a dot size minus 1. Offset is 1. Okay. Big money, no whammies. Uh-oh. X down x modulus 10x and 2 inch. Great array deck. Long is fine. Oh, why cannot be reassigned? A to pair these guys. All right, change from X into array. Uh-oh. What? No method providing array access. No way. Really? I thought an array deck would be fine. This thing a deck. An array. Tag to list. Unresolved reference. Really? No set or providing array access to array. I think you could have a to int. It's not like that. Not one bit. Let's see. This too long. Some ambiguous. What the heck? And to int array, maybe? To int array. Too long array. Let's do this. Change this. Change that. to int t reason to be transformed to long integers. Okay, 4. That's not right. Offset times this guy. Zero that guy out. Sure is taking a while. Okay, that looks good. Big money, no whammies. Oh, uh-oh. Interesting. What's going on here? Need. Oh, maybe I do need to keep it as long. Okay. Plus 10. Cumulative sum. This guy. Let's do this. X T dot 2 long. T underscore T. Okay, so long. Uh-oh. Offset that along as well. Need I offset. Okay. Big money, no whammies. Uh-oh. Oh, it's a triple. Okay, that looks good. And this guy should be 393. Looks good. Big money, no whammies. Yay. Okay, there's Kotlin. And how much time do we have left? We have 2 minutes. Okay, 2 minutes. Let's do C++ real quick. X T long L need yeah, there's a vector long X. I guess we call this thing a stack. Okay, so A pick, yeah, push front X minus 10. X divided by equals 10. Okay, so we'll accumulate a, oops, again, and 0 LL. Okay, that exceeds our threshold. Need plus equals offset times a sub I, whatever difference is to get up to 10. So I is zeroed out. If I minus 1 exceeds 0, then we'll carry the 0 over. I offset times equals 10. Offset and I aren't defined. Hold on. I'll do I offset is make pair. Integer a size minus 1. Offset is 1. Oh. Okay, something like that. Looks good. Big money. All right. Just in time. 9 seconds left. Clutch maneuver. Okay, cool. Post that. Call it a day. Upsolve Q4. Right. Transform the digit X. Input digit X into an array of digits, and zero out the digits of A. from right to left to accumulate what we need for the sum of A to be less than or equal to threshold T. Looks good. Nothing too fancy. Cool. All right. Catch you next time.